in LGIT. Student, welcome to session of modern serving instrument. So, in a first session of modern serving instrument, I have explained some introduction part, electromagnetic waves properties and properties of electromagnetic spectrum. So, student, you know that a different type of instrument are used in a serving, like chain, tap, compass, theodolite, tachyometer, total station, auto level for conducting the survey. You know that in a survey, the distance is usually measured directly with a tap or chain. This method is known as the direct distance measurement method. Like example, you have find the distance between 2 points and taking the tap or chain, so you directly find the distance between them. So this method is called as a direct distance measurement method. In a survey, there are three types of method. One is a direct distance measurement. Second is the indirect, means here is called as a optical distance measurement. And third is the electromagnetic distance measurement. So student, in this chapter, I have explained about the electromagnetic distance measurement instrument. So first method is a direct distance measurement method. Now, direct distance measurement method is a quite convenient in a most of the case and good accuracy can be achieved. But this method is unsuitable in a difficult terrain and sometimes impossible of obstruction occur. Means where obstruction is more, so impossible to have directly taken the distance measurement. So this is the limitation of this method. So that the problem was overcome after the development of optical distance measurement. So now role of the instrument is called as the optical distance measurement. The distance can measure indirectly using the optical distance measurement instrument called as a tachyometer. You know that I have already explained a tachyometer in a tachyometric serving session. So this is the optical distance measurement instrument. So however, tachyometer are not suitable where high accuracy is required. So the accuracy obtained is in 1 in 1000 to 1 in 10,000, also range to 100 to the 150 meter. So tachyometer are generally used for short distance because here its accuracy is low, 1 in 1000 to 1 in 10,000, and also range also is the short 100 to 150 meter. But nowadays a survey project, the distance is a larger, so this type of instrument is outdated. Why? Because such innovation are still continue and and leaving behind the conventional instrument and method, so that this instrument is outdated. So some modern equipment are like auto level, micro optics, theodolite, and electronics or digital theodolite. This type of instrument or equipment are used for conducting the survey. So these type of equipments have become a very popular because of simplicity and operation ease and speed of working. So in this chapter or main scope of this chapter, understanding of the modern serving instrument like total station, electromagnetic distance measurement method, instrument. Next is a digital level, GPS for finding the location. So in this session means in a modern serving instrument, in all the session you have a study about this type of instrument. Now electronic distance measurement instrument or electromagnetic distance measuring instrument have been recently developed, which is give high accuracy in distance instrument. Because you know that in India or all the country, the construction project are more other than the other field. So main factor is speed of working. So and giving a high accuracy because larger project are there. So accuracy is a main factor and speed of working. So this type of condition you have used this type of instrument like electromagnetic or electronic distance measurement instrument. So nowadays recently This type of instrument are used. So in this session I have explained different type of uh, or different type of method and which are the instrument are used particularly based on this method. You know that first direct distance measurement, you have used the chain or tape for taking the distance or taking the measurement. Second is the theodolite. You know that theodolite are used for finding the, or tachyometer are used for finding the horizontal distance as well as vertical distance, horizontal angle as well as vertical angle. So the inner instrument, some optics are used for finding this type of measurement. So it's called the optical distance measurement. And third is the electronic distance measurement. These instruments are based on the property of electromagnetic wave. I have explained in a next slide. So electronic distance measurement. This is the first photograph. In a first photograph, this is the EDM, electromagnetic distance measurement. This is a digital level, and third is the digital theodolite. But nowadays, the addition of or combination of EDM and digital theodolite equal to total station is the most usable instrument nowadays on a field. So I have explained in next session what is a total station and use of total station. I will explain in next session. Now I have given only overview a different type of electromagnetic or electronic distance measurement instrument. Now, electronic distance measurement or electromagnetic distance measurement are based on property of electromagnetic waves. Particularly in this session, I will explain about electromagnetic waves and as well as the electromagnetic spectrum. So, first I have explained electromagnetic waves. The EDM method is based on generation, propagation, reflection and subsequent reception of electromagnetic waves. So the EDM means electromagnetic distance measurement is based on the waves, the path of waves. Like first, you know that waves are generated, then propagation, then deflection to object, and last is a reception of this wave. So you have studied about the first electromagnetic wave. Now the distance is measured indirectly using the characteristics of this wave. You know that our main goal is to find the horizontal distance as well as the vertical distance. So the distance is measured in a EDM, means electromagnetic distance measurement, indirectly method and using characteristics of this wave. So you have studied about the student characteristics of wave. You are already studied in a physics in a 12th standard, but I have repeating in this session. So first, the electromagnetic waves require no medium and they can travel in a vacuum. This is a diagram, you know that. This is a y direction, x direction. I have explained lambda means wavelength. I have explained about the frequency, what is the frequency, what is the wavelength, and what is the cycle or what is the velocity of this particular waves. So I have explained in detail. So these are a major 5 properties of electromagnetic waves or characteristics. So first is a cycle. When the wave moves through two identical point on its path, it is said to have completed one cycle. You know that here the cycle A to E means here waves are generated at point A and reach the point E. So these one cycle are completed. So cycle means when the wave moves through two identical points like A to E, example, second example B to F, third example C to G. So this is called as a cycle. Now wavelength. The length traversed in x direction by the wave, then its complete one cycle is called the wavelength, is lambda. Means the length of the or the length traversed in x direction by the wave. Here lambda is clearly I have seen means here the waves are traverse in a or movement in a x direction. So the traverse in a x direction by the wave, it's complete one cycle. One cycle means A to E, B to E, F. So this is called as a one cycle. So complete one cycle is called as the wavelength. So this is the wavelength. Now third is the frequency. The number of cycle completed by the wave in a 1 second is called as a frequency. So the number of cycle completed by wave in a 1 second. You know that you have already studied in a physics in a 10, 12 standard. The unit of frequency is a hertz, you know that, which is equal to the 1 cycle per second. So frequency unit is a hertz and which is equal to the 1 cycle per second. Now time. The time taken by the wave to travel through one cycle, a distance equal to one wave length is known as the period. It is represented by the t, and t is unit is a cycle. So the time taken by the wave to travel one cycle means the waves had started from A to E, and the time is called as a means taken a time to reach the or complete the one cycle is called as a time, and its unit is a second. And last property of electromagnetic wave is the velocity. So the velocity v of the wave is the distance traveled by in a 1 second. You know that distance upon time. So distance traveled by in a 1 second. So you know that t equal to 1 upon f. So lambda equal to v into t. V is the velocity into time. So f equal to, you have replaced these terms. So frequency equal to v upon lambda. So v is the velocity and lambda is the wavelength. So the velocity v of the wave is the distance traveled by in 1 second. You know that velocity equal to distance upon time. So distance traveled by in a 1 second of the wave is called as the velocity. So these are a property of electromagnetic waves, because this is important to understanding the instrument like total station or understanding the principle of electromagnetic distance measurement. So this is the most important topic. Now, after understanding the electromagnetic waves, next is the electromagnetic spectrum. So electromagnetic spectrum is the name is given a cluster of radiation that carry energy. It is the one cluster of radiation, like you know that radio wave, microwave, and infrared, visible, ultraviolet, X-ray, and gamma rays. These are a different type of electromagnetic waves. So the understanding of these waves, all the waves, you have make one cluster. So the name is given a cluster of radiation that carry the energy is called as the electromagnetic spectrum. Now, distribution of the continuum of all radiant energies can be plotted either as a function of wavelength or frequency in a chart known as the electromagnetic spectrum. So these are a second definition of electromagnetic spectrum. Like you know that the energy can or all radiant energy can be plotted as a wavelength or a frequency in a chart, means the in a or making the graph between the wavelength or frequency and understanding the all the distribution of the continuum of all radiant energy. So this chart is most important. So this chart is known as the electromagnetic spectrum. So first definition, the name is given to cluster of all the radiation that carry the energy is called the electromagnetic spectrum. Or second definition is called as the either as a function of wavelength and frequency in a chart, understanding in this chart, and this name is known as, or called as the electromagnetic spectrum. Now, it ranges from shorter wavelength to or included X-ray and gamma rays to the longer wavelength like microwave waves or radio waves. So, electromagnetic spectrum means plotted on shorter wavelength to the larger wavelength. So shorter wavelength, you know that X-ray and gamma rays where wavelength is a very small, and in a microwave and radio waves, you know that wavelength is the distance or length is the larger than the X-ray or gamma rays. So electromagnetic spectrum are understanding the all the type of radiation like shorter wavelength to the longer wavelength. Now, electromagnetic spectrum is the range of all possible frequency of electromagnetic radiation. So, electromagnetic spectrum is the range of all possible frequency. Like you know that here one funda is there, smaller wavelength, so higher frequency, longer wavelength, so frequency is a low. So here electromagnetic spectrum is a understanding about the all the possible frequency and electromagnetic radiation. And EMR means electromagnetic radiation extend over a wide range of energy or wavelength or frequency. Here clearly seen the visible portion of the electromagnetic spectrum. Here first gamma rays, then X-ray, then visible light, then microwave and radio wave. Here frequency in increase in a gamma rays or X-ray and wavelength is decrease. Here frequency is decrease and wavelength is in a increase. So is a vice versa. In a portion of X-ray and gamma rays, frequency increase because the distance or wavelength is in a shorter side, so shorter wavelength. So here frequency is increase, and here above the microwave and radio wave, here frequency decrease. Why? Because wavelength is in a longer way. So wavelength is in increase, so frequency is decrease. Now I have explained in a detail. This is a electromagnetic spectrum diagram. You know that the first gamma rays here frequent wavelength is a smaller, so smaller wavelength, so frequency is high. Then after the wavelength means here the size of wavelength is a longer side, so its frequency is a lower side. Now, electromagnetic waves form a continuous series in an order of changing the wavelength and frequency and energy. This series is called the electromagnetic spectrum. So, the third definition of electromagnetic spectrum is that electromagnetic waves form a continuous series in an order of changing the wavelength and frequency and energy. This series is called the electromagnetic spectrum. You already know changing in a wavelength. Here, wavelength is a smaller, then after the a wavelength in a longer way. So changing this wavelength or changing this frequency or changing in a energy, this series is called as a electromagnetic spectrum. However, all these travel with a velocity approximately equal to 3 into 10 raised to 8 meter per second. The velocity forms basis of all the electromagnetic measurement. So you have considered the in an electromagnetic distance measurement instrument means EDM or total station. You have considered the velocity of this wave. It travel by 3 into 10 raised to meter per second. So the velocity forms basic basis of all electromagnetic measurement. Now, here, so next diagram, what are the property of electromagnetic spectrum? So you know that these are first wavelength. You know that the electromagnetic spectrum series of wavelength and frequency and energy. So first is a gamma rays. So here wavelength is a means frequency is high and wavelength size is small. Then after X-ray, wavelength are decreases. Similar that here in a up to the radio wave, here wavelength is a in a size is larger, so frequency is a lesser. So gamma rays, X-rays, you know that UV means ultraviolet, visible light, then infrared, then microwave, and now it is a radio wave. So in a electromagnetic distance or EDM instrument are based on ultraviolet and visible light, and third is the infrared. So first in a first the electromagnetic distance measurement are found of form of microwave instrument, then visible light instrument, and then infrared instrument. So in this session, student, I will explain about the what is the properties of electromagnetic wave and what is the property of electromagnetic spectrum, and uh, introduction part about the electromagnetic distance measure, optical distance measurement method, and direct distance measurement method. So thank you so much for watching this video.